Alright, so when we solve problems, we have to set up free body diagrams most of the time. And anytime that we're talking about a situation that's in equilibrium, we're talking about an object that is either moving at a constant velocity or not moving at all. So equilibrium has two types. There's static, which has to do with not moving, and translational, which has to do with moving with a constant velocity. So when we're moving with a constant velocity, we need to be in a state of equilibrium in terms of translational equilibrium. And translational equilibrium simply means that the net force acting on your system has to be 0 newtons. And in order to have a net force, what we have is a summation. And the net force just means that the forces to the left and the forces to the right together equal nothing. So when you look at a particular situation, you have to first identify what forces you have acting on what direction, and then go from there. So when this happens, you need to have a perfect balance on your situation in all directions. So equilibrium can occur if you have forces pointing in all directions. So a force this way needs to be balanced by a force this way. And if you have a force this way, it has to be balanced by a force this way. That's totally equal in size. You can't get away from having the sizes equivalent. So the only way for this to actually happen is to make sure that in your system you end up with values for force that are equivalent. So the other option is to recognize that equal forces have to be equal in size. They don't have to be equal in number. So you could have forces like so, pointing in this direction, and only one going this way, so long as the numerical value of these three together is equivalent to the value of the one on the left. So if all of these together equal 10, that means that this force over here, also needs to equal 10. And that's how your system will be balanced and will be in equilibrium.